Hello everyone. This video is to give you a detailed introduction to our final year project, which is Machine Learning based Corporate ESG Ranking. First of all, what is ESG? ESG is a set of standards for a company's behavior used by socially conscious investors to screen potential investment. In simple words, a company's performance on environment, social, and governance aspects are evaluated by these ratings. These ratings are useful for many parties such as investors, corporate managers, competitors, and shareholders, and other parties which are interested in that specific company.
There are multiple ESG rating providers offering up-to-date ESG rating to companies in the market, such as Refinitiv, MSCI, ISS ESG, Bloomberg, and Sustainalytics. ESG rating scales differ from one rating provider to another. For example, Sustainalytics provides 0 to 100 scale for ESG risk rating, where lower score indicate better ESG risk management. In Refinitiv, they adopt a 0 to 100 scale for ESG rating, with a higher score indicate a better overall ESG performance. MSCI uses a letter rating system, classifying a company into 7 ESG classes and 3 basic classes, reflecting their ESG performance. There are multiple issues with the current ESG providers, such as not disclosing the ESG rating calculation methodology or the data sources, and expensive and time-consuming due to manual labor, and low-level agreement with each other.
The solution that we present is a fully automated method of generating ESG insights using machine learning from publicly available financial and news data. The use of publicly available data eliminates any concerns about bias that may be present in the rating company's processes, and the machine learning approach will enable this solution to be adapted in an automated manner without involvement of manual estimates, reducing labor costs and the possibility of human error. In addition, the methodology will be open source so as to boost investor confidence and remain open for further improvements. So there are 3 main sources of data involved in this project. The first is financial data from macrotrends.net, and this covers the financial features of all the companies, which are extracted from their cash flow statement, balance sheet, income statement, and other financial statements. The second dataset involved is the news dataset, which was taken from benzinga.com, and this dataset includes the headlines and content of various news articles mentioning these companies in some form. And finally, the third dataset is, of course, the target ESG ratings dataset. The target ESG ratings for this study were taken from MSCI, which is a known provider of ESG ratings. MSCI ESG ratings can range from AAA to CCC, AAA being the highest and CCC being the lowest. All in all, there are 7 classes. So these 3 datasets are relevant to the SB 500 companies over the time period of 2017 to 2022, therefore covering a period of about 5 to 6 years. So this study is split into 3 main avenues of research, which present the potential to be combined commercially into a comprehensive and informative ESG rating system. The first is the prediction of annual ESG ratings based only on data for that particular year. That is, without knowing the history of that company's ESG performance, we predict a brand new rating entirely from scratch. This allows an ESG rating system to be initialized for the first time in companies that were not previously covered. The second avenue of research is the prediction of yearly changes in the ESG rating, that being whether it increases, decreases, or remains the same. And this is based on the corresponding changes in the financial parameters of the company. This can help us explore the relationship between specific financial parameters and ESG ratings more closely, and also helps investors anticipate short-term changes and act accordingly. The third is the forecasting of ESG ratings for a longer period, perhaps multiple quarters or years into the future. This helps investors gain an idea about possible future changes in the company's ESG and take a longer-term approach to investing. So moving on to the architecture of the annual prediction model, which was the first avenue of research mentioned previously. In this diagram, you see the 2 sources of data. news headlines on the left and financial data on the right. The news headlines are filtered through pre-trained natural language processing models, which were specifically trained to classify text into one of the four categories, which would be environmental, social, governance, or other, or based on sentiment, which would be positive, negative, or neutral. So, according to this, any combination of criteria can be selected, and we eventually filter only the articles which are relevant to ESG in some way, but of any sentiment. These filtered texts are then fed into ESG Bird, which is another pre-trained model whose purpose is to classify a text into one of 25 ESG subcategories. We remove the last layer of this model and take the outputs of the layer immediately preceding it. By doing this, we obtain a representation of how that model internally recognizes the ESG aspects present in the text. This output vector is processed using principal component analysis to reduce its dimension and is then fed alongside the preprocessed and filtered financial features into a classification model, which gives the final rating as a single ESG class out of the 7 that we mentioned previously. Experiments with this model confirmed that the addition of news data into the model helped it to perform better than if only financial data was used. This has significant implications for the research in this field, which previously focused on using only either financial or news data and did not consider the combination of the two.
Next approach is ESG change prediction. Here, predicted whether the ESG rating of a company will increase, decrease, or remain unchanged compared to the previous year's ESG rating using only financial data. Therefore, the percentage change of financial features compared to the previous year was used as a proxy for company's overall performance change. This is the architecture diagram of change prediction model. Different classification models like XGBoost, CatBoost, and Random Burst was used to classify companies into 3 classes.
When it comes to multivariate time series analysis, first we have to design the structure of our dataset as panels. A panel dataset is a combination of time series data and single measurement data. After converting the financial data of S&P 500 companies into a panel dataset, we get a 3D dataset with 3 dimensions, which are features, quarters, and companies. This dataset is the one we are using to train the time series model. The architecture of the time series analysis is shown here. An LSTM model is used here since it can capture the long-term dependencies of sequential data. The model consists 3 LSTM layers and 2 dropout layers with 1 dense layer at the end. The model compiled with mean squared error as the loss function, Adam as the optimizer, and mean absolute error as the evaluation metric.
Conclusion and future work. This research intended to create an automated ESG score builder for companies globally. Here experimented with 3 main approaches: classification based on current financial and textual data, prediction of ESG rating change using only financial ratio change, multivariate time series analysis on ESG ratings. Future experiments can be conducted with different ESG data sources, considering more financial and non-financial variables. Also, future work aims to integrate 3 approaches, leveraging current data to create a comprehensive automated ESG score builder which predict future ESG rating changes and analyze temporal patterns in ESG ratings.